Welcome, y'all, back to some more geometry. Today, we're talking about parallel lines and proportional parts. So, part of parallel lines have been special throughout all geometry. We're talking about, they forms congruent angles, consecutive interior angles, consecutive interior angles. They have such similarity to each other. They make things happen. But first, let's talk about the proportional part side of this thing. So, right here is saying that hey, you have some point L and some point M in these two lines. Now, because of the way these points are in here, if we could show that these two sides are proportionally the ratio of these two sides are proportional to the ratio of the other two parts of that line, then we can go ahead and say that these lines have been divided proportionally. That means these lines were ultimately similar, and because of the way these points on the inside were placed, this is similar to this, and this is similar to this. Okay, they're similar to each other. All right. Okay, that kind of leads to this triangle proportionality theorem. Before, this is what we used to do. If you want to pause to read this, you can. But before, this is what we used to do. We used to compare whole triangles to the whole thing. So if we were looking for x, we would have done like, hey, 10 is to x. So small side of the triangle is to the large counterpart. As the small side of this triangle is to its large counterpart, the whole thing, which will be 30, what is it, 39? Yeah, 39. That's what we used to do, okay? And we're still going to do that. You can still do that at times like this. That's probably the easier thing to do if you're given this information right here. So as we set this up, we'll go ahead and cross multiply. We end up getting 15, there you go, 15x equals 390. So we take 390 divided by 15, and we get 26. So x equals 26. And that seems pretty correct proportionally wise right there. Now, because parallel lines are intersecting, these two lines right here parallel, and they intersect both lines intersect the same sides over here and over here, and then over here and over here. We are going to say that these two parts have been divided proportionally to each other. So the proportion from here to here should be the same as the proportion from here to here. So why does that matter? Well, because now we don't necessarily have to know the whole thing. The whole thing. For example, we don't know this whole thing, but we can say, hey, 4 is proportional to 5, as 6 is proportional, let me put an x, to x over here. 6 is proportional to x. Okay. Now we still could have done, hey, 4 is to the whole thing. We could have done 4 is to 9, as 6 is to 6 plus x. But hey, why deal with that? This is smaller numbers, and a little bit, once we solve for x, that's what we're looking for right there. There's no reason to do 6 plus x and then subtract and then divide. Here we can just cross multiply. We get 30 equals 4x. Divide by 4. What do we get, y'all? 30 divided by 4? 7.5. So 7.5 equals x. Now, will it work over here? We did this? Yeah, let's try it out. So let's cross multiply. We get 9 times 6, 54 equals 4 times 6, 24, plus 4 times x, 4x. Subtract 24. We still get 30 equals 4x, and then we divide by 4, we still get the same thing. Okay, so you can do either one, but here you can just compare parts to parts, parts to parts. That's what parallel lines do. It divides them proportionally. Now, either one of these ways of doing it is not necessarily there's no one right way. Some takes a little bit less math. Here we went straight to the 30 equals 4x. Here we had to subtract to get to the 30 equals 4x. So it just saves you some time. Now, where it kind of starts changing a little bit is things like this. Let's look at this. First, let's talk about what a mid-segment of a triangle. So I understand all these highlighted words, they're going to be vocabulary you will see on tests. They're going to be things that they're going to just ask you, hey, if the mid-segment does this, what is the value of these sides, as we're about to do right here? So a mid-segment, what it does is connects the endpoints of that segment, divides those sides in half. Okay, divides in half. So Excuse me. So according to this theorem, a mid-segment of a triangle is parallel. So the mid-segment is parallel to one side. Then that mid-segment is half the value of the sides it's parallel to. Okay? So, oh, used the wrong number. That should have been over here. That should have been over here. Let's do it over here. 30. Okay, so if this mid-segment, because this is a mid segment, because these two sides are equal to each other, A to B and B to C, and A to F and F to E, that means this mid-segment right here cut these two sides proportionally, equal, congruent. And because it did that, the side is parallel to, so this side right here, BF, is parallel to this side over here, CE. So the value of this is half of the value of this whole side. So if this is 5, what's the value of CE right there? 10. Yeah, it's double that. So that being said, you see the double lines right here? This is a double parallel. So these two are parallel to this side. So if this whole side right here is 40, what is the value of B to D? Yeah, half of that, 20. So if this is 30, this side is parallel to, it's half of that, 15. So as we can take this and double it to get one side, or we can take the sides and half it to get our mid segment. So mid segment times 2 equals side, well, parallel side, side's parallel to, or parallel side divided by 2 equals the mid segment is parallel to. Okay, so vice versa, they both kind of go one to the other depending on what you're trying to solve. It looks like 11, but it's parallel. You just do slanted lines means parallel. Slanted lines. Parallel. According to this theorem right here. Okay. Now, to add on to that, this corollary says, hey, if you have 3 parallel lines that are parallel to each other, and they just intersect 2 other lines regardless, 2 transversals. Now you see, this is a little bit more slanted to this, so they're not equal in any way, shape, or form. They're not going the same pattern. And these are not evenly spaced. But if you have these 3 lines that are parallel to each other and they intersect 2 transversals, then it divides this transversal. So this transversal and this transversal have both been divided proportionally. So the proportion from here to here is similar to the proportion from here to here. Now there's 2 ways to go about this. So we're going to solve for x here. But let's kind of look at this first. You can set it up one way. You can say, hey, you can look at just one transversal, big side over small side. You can say, hey, 4x is to 3x, as long as you do the same thing here, big side over small side, is proportional to 5x over 15. So we do the same thing to cross multiply. So we cross multiply, and we get 15x squared equals, what will that give me, 60? 60x right there. Now, as we do the math, you're like, whoa, there's an x squared and x. That's okay. It's not going to really do it. Let's divide both sides by at least 1x right there. When we do that, that goes away, leaving me just 60. On this side, it reduces one of them, giving me 15x. And then you can divide by 15. We find that x equals 4. And then you can substitute that in here. Now, we did top to bottom, top to bottom. Another way you can do this is proportion. You can set your proportion side to side as long as you do the same way on the other one. If I'm going left to right, then I do left to right. If I can go right to left as long as I set it up as right to left. So 4x is to 5x as 3x is to 15. So what you do on one part, you have to do the same part in the same manner. We still cross multiply. We still end up getting 15x squared equals 60x right there. And then you solve it the other way. You solve for x. If we were to go the other way, you still ultimately get the same that. Right to left over right to left. And you can also go bottom to top, as long as you follow the same pattern. Understand, this whole thing is about patterns. Do the same thing. Now, so that's this corollary here. To add on to that, corollary 7.2 says, and this is a little bit more specific, if you know that your lines, your parallel lines are kind of transversal, again, these transversals are not equal to each other, the distance between here and here, not necessarily equal as it is here to here, or this is not equal to that, that's not equal to that. But if you know that your parallel lines, when you draw the 3 parallel lines, cuts your transversal 2 equal parts on one side, then all other parts are cut evenly. So if I were to draw a third transversal that kind of goes diagonally across, let's say something like that right there. Yeah, like that. The distance, let me get my pen back out. The distance from here to here will be congruent to the distance from here to here. So these 2 little segments are congruent to each other. So that's what this is saying. Now, these segment, this equals that. They equal each other. These 2 equal each other. So instead of setting the proportions like we were last time right here, we do this over this equals this over this. We can say, hey, 9y minus 2 is 2 equals, my pin's being a little odd, equals 6y plus 4. We'll solve for y, and over here to solve for x, we would do, change colors, we do, hey, 3x minus 7 equals x plus 5. So if you know that one side got cut congruently, then all other transversals got cut congruently. So start with this time right here. So we'll go ahead and we'll add 2, and then we'll subtract 6y to the bigger side. We're left with 3y. That goes away, equals 6. Divided by 3, y'all. You get y equals 2. All right, let's check out x now. So go ahead and solve that. Pause, solve, and then we'll compare. So same thing right here. We're going to subtract x to the bigger side minus x minus, and then add 7 to that side. Bam, bam. We're left with, we subtracted, so it'd be 2. 2x equals 7, 8, 9, 10, 11, 12, 12. So x equals 6. Divided by 2, divided by 2. Okay, those are our 2 answers we're looking for right here. Hopefully that helps y'all. Y'all have an amazing, amazing day. Bye.